Welcome to SGITMystr. Today, we're going beyond prompt engineering. We connect MCP and skills to build a truly smarter AI. Let's unlock the true future of artificial intelligence right now.
We'll really completely demystify how to build robust AI agents that go way beyond basic prompt engineering. We'll show you exactly how to give your models the specific, unique data they actually need to be useful for your complex use cases. Here's our roadmap for today. We're covering 4 main areas: the context engineering shift, the model context protocol, or MCP, reusable AI skills, and finally, a breakdown of which one you should actually choose. Let's jump right into section 1, the context engineering shift. So before we can actually build an agent, we have to understand the core limitation we're trying to solve. Think of an LLM as this massive, generalized crystal ball prediction machine. It's read mountains of information, books, forums, you name it. It's totally fine at reciting generalized facts, like, say, the history of Red Hat, or explaining basic database theory. But here's the catch. It fundamentally lacks the specific context of your unique, private data. It might know how databases work in theory, but it has literally no idea how your specific team's database is configured. Getting the right answer means providing the right context. And this brings us to a massive paradigm shift in how we interact with AI. We're moving away from basic prompt engineering and stepping right into the era of context engineering. Prompt engineering on its own is really just giving a task to the LLM. You ask a question, maybe assign it a persona, and that's it. But context engineering, that's where things get really fascinating. This is where we actively feed the model the precise environmental data it needs to generate highly accurate custom answers. We're talking about injecting external data, strict formatting rules, live database configurations, and actual tool responses directly into the model's context window. The big question, though, is how do we actually pull this off securely and efficiently? That leads us to section 2, the Model Context Protocol, or MCP. The absolute first major tool in our context engineering tool belt is MCP. Imagine your AI agent needs to update some customer contact info stored securely in your CRM. How exactly do we get that data into the LLM? Well, we definitely can't just blindly copy and paste our private API documentation and secure access tokens straight into a text prompt, tell the LLM to make no mistakes, and just cross our fingers. That's a massive security nightmare, and honestly, it's incredibly unreliable. That's where MCP comes in. It acts as this secure, standardized abstraction layer between your AI model and those external data sources. It totally standardizes how your AI talks to different services. So instead of exposing raw API keys in your prompts, MCP abstracts those service APIs into a really simple LLM-ready format. And crucially, it provides scoped authentication. That ensures your agent only ever has the specific read or write access it actually needs to get its job done. Let's look at how this actually works under the hood. By adding an MCP server to your IDE or your AI app, you're essentially creating a bridge. In step 1, the LLM realizes it needs external info and spits out a highly specific JSON request. In step 2, the MCP server catches that JSON and securely translates it into standard GET or POST HTTP requests. Finally, in step 3, the actual secure API call is made out to the service to fetch the live data, which is then fed right back to the LLM. The big takeaway here is that MCP is a heavy, tightly permissioned integration layer. Think of it as the ultimate gatekeeper between your agent and your live tools. Because of this, it's absolutely perfect for real-time integrations where security and state are everything. If you need your AI to check what VMs are currently running, or analyze the live state of a Kubernetes cluster, or safely pull live customer records, MCP is exactly what you need. It seamlessly hands the LLM that external data. Moving right along to section 3, reusable AI skills. Now, while MCP handles external data beautifully, we still need a way to teach the LLM repeatable domain knowledge. Let's say MCP successfully pulled those customer records from our CRM. Awesome. But now our sales team is demanding that this data be formatted perfectly, the exact same way, every single time. And if you've spent any time with LLMs, you know they are inherently non-deterministic. They love to change things up just for fun. If our sales team needs a report that includes the customer's name, their contact info, and, very importantly, their favorite type of cookie, we literally cannot afford for the model to just forget the cookie data on Tuesday because it felt like formatting the report differently. We need strict consistency. And that is exactly what AI skills solve. They act as these lightweight, deterministic rulebooks that teach your model exactly how to behave for highly specific tasks. If MCP is the secure phone line to the outside world, a skill is the training manual the AI reads right before it picks up that phone. Skills are just incredible for tasks where you need highly repeatable outputs, things like cleaning up messy Excel documents, running strict compliance checks, or executing a very specific code debugging routine that your engineering team prefers. Structurally speaking, a skill is elegantly simple. It's basically just a folder. Inside, you have the title of the skill and a description. Now, that description is vital because it tells the system exactly when to auto-load this skill into the LLM's context window. Underneath that, you have the core prompt, usually just written as a simple markdown file, which acts as the strict instructions for the LLM. You can even toss additional scripts and resources into this folder. What's brilliant about this is the efficiency. If you have a code debugger skill, it only gets loaded into the context window when you are actually asking the AI about code errors. It doesn't clutter up the model's memory when you're, say, just asking it to draft a quick email. Which brings us to our final section, Section 4. Which should you choose? Now that we've got a solid handle on both architectures, let's put them head to head. Looking at their primary roles, MCP is all about connecting to secure, live, external data. Skills, on the flip side, are all about providing repeatable, internal domain logic and formatting. When it comes to system weight, MCP is a heavier, tightly permissioned API layer. It's a real infrastructure integration. Setting it up would be total overkill if you just want to format some text. Skills are incredibly lightweight, modular markdown files. So, the rule of thumb, use MCP when your agent needs to fetch real-time data from CRM databases, check active VMs, or ping secure clusters. Use skills when you need to teach the model a custom capability, like how to format an output exactly the same way every time, or how to debug code using your company's specific best practices. Honestly, the best news for developers and tech enthusiasts watching this explainer is that you don't have to wait around to start experimenting. Both of these context engineering tools, MCP and reusable AI skills, are entirely open source. They're already widely adopted and supported across most of the major AI tools out there, and you can literally start running them locally on your machine today to enhance the context window of your own LLMs. As we wrap up this explainer, I want to leave you with a final thought to chew on. We've mastered connecting external data with MCP, and we've mastered teaching the model repeatable behaviors with skills. But how do we actually interface with these highly capable agents day to day as developers? With MCP and skills firmly in place, our command line interfaces, good old CLIs, the next major frontier in agent development and interaction? Think about how incredibly powerful a fully context-aware CLI could be for your daily workflows. It's definitely something to think about as you keep exploring the amazing world of context engineering.